Scalar product of vectors. The definition of a scalar product. We define it, scalar product of two vectors, as we've got vector 1 and vector 2. We get the ones in front of the i's and we multiply them together, get the ones in front of the j's, multiply them together and add them up. That gives us the scalar product. So for these two here, an example is 2 times the 1 plus 3 times the negative 4, which gives us the negative 10. It's also called a dot product. If a equals 0 or b equals 0, then a, b will equal 0. Geometric description of the scalar product. So for two vectors a and b, we have a times b, we equal the magnitude of a, the magnitude of b, cos theta. Theta is the angle between a and b. Number 10. If a magnitude of a equals 4, magnitude of b is 5, and the angle between a and b is 30 degrees, find AB. So I might as well use the rule here. So they told us that AB equaled magnitude of A, which is 4, times the magnitude of B, which is 5, times cos of the angle between them, which is 30 degrees. So if I work this out, I've got 20 times cos of 30 is the square root of 3 on 2. So I've got 10 the square root of 3. Part B. If A magnitude of A is 4, magnitude of B is 5, and the angle between A and B is 150 degrees, find AB. So again, I'll use the rule. Magnitude of A, which is 4, magnitude of B is 5, times cos of 150 degrees. Now remember, 150 degrees is in this quadrant, and cos in that quadrant is negative. So we've got 20 times negative the square root of 3 on 2, which gives us negative 10 the square root of 3. Properties of the scalar product. So some properties that probably are good to know and remember. So A times B is the same as B times A. If we've got a scalar on the outside, that's just the same. We can multiply it by the A or multiply it by the B, doesn't matter. If we're multiplying by 0, we're going to get 0. If there's a bracket, just like normal thing, it's multiplying both the B and the C by the A, and A times A is just A squared. If the vectors are perpendicular, then A times B is 0. If A times B equals 0 for non-zero vectors A and B, then the vectors A and B are perpendicular, which means it's opposite way of that. So it works both ways. For parallel vectors A and B, we have AB equals magnitude of A, magnitude of B, if A and B are parallel in the same direction, and negative magnitude of A magnitude of B if A and B are parallel but in the opposite directions. And we can find the magnitude of the angles between two vectors by using that rule. Rearrange that rule is just that, or we can use that one, it doesn't really matter. Example 11. A, B and C are points defined by the position vectors A, B and C respectively, where A is that, B is that, and C is that. Find the magnitude of angle A, B, C. So just to give you an idea, we've got a vector here, one here, one here. Okay, there's our A, there's our B, there's our C. Okay, so we have to sort of think about things like this. So the angle A, B, C will be the angle between BA and BC. Okay, so that one there. Okay, so BA will equal A minus B. Doesn't matter if you do B minus A, we only want to find this. Now A minus B, I better write it down here, is 1 plus 3j minus, that's the whole thing, so 2i minus j. So when we work this out, we're going to get minus I plus 2j. And BC will equal C minus B, and when I work that out, it's going to be minus I minus 3j. Okay, so I've got that one. Now we're going to apply the rule that they gave us before. So down the bottom, it was BA times BC, which will equal minus I plus 2J times minus I minus 3J. And when I work that out, I'm going to get 1 minus 6, which means I've got negative 5. So that's that part there. I need the magnitude of them. So the magnitude of BA will equal square root of 1 plus 4, which means it's the square root of 5. And I need the magnitude of BC, which means it's the square root of 1 plus 9, which is the square root of 10. And now write in the rule cos of the angle ABC equals BA times BC. We already worked that out. It's up the top, divided by the magnitude of BA times the magnitude of BC, which we also worked out. So that means I have negative 5 divided by square root of 5 times the square root of 10, which means it will give me negative 1/2. Of course, inverse cos of negative 1/2. Therefore, angle ABC will equal 3 pi on 4, because cos a half is pi on 4, but I want the negative, so it's going to be, I'll do this in red, pi minus pi on 4, which will give me 3 pi on 4.